The corrections to the ordinary level probability and statistics exam. Okay, so we have a bag containing 8 cards, each with a shape on it, as shown below. One card is picked at random from the bag. The box below shows the terms that can be used to describe the probability that an event happens. So it could be unlikely, certain, likely, impossible, or equal chance. Okay, so the first one is the card picked has a circle on it. So that is 1, 2, 3. So it's 4 circles out of how many cards? Oh, 8. Okay, so that's half, which means it's this one. Okay, equal chance, because it was 4 out of 8. The card picked has a rectangle on it. There is no rectangle, so that's going to be impossible. Can't pick it if it's not there. The card picked has a shape on it. Well, every single card has a shape on it, so that is certain that you pick a card and there's a shape on it. The card picked has a diamond on it. It's just one of them, so it's 1 out of 8. So that's quite, unlikely. And is that it? Oh yeah. Okay. Okay, so likely was a red herring there. You didn't need it. Keep going. Write each of the letters A, B, C, D in the correct place on the scale below. Okay. So equal chance for A. So I need my dot, need some kind of a mark, and then the letter. Impossible for B would be over here and B. Certain for C would be here and here, and then 1/8 for D would be here. Okay, you need the dot and the letter. And that's question 1. Question 2. Fionn rolls a fair 6-sided die and spins a fair spinner with 3 equal sectors numbered 1 to 3, as below. The results of the die and the spinner are then added together. Okay, so they're added, that's important. Complete the table. So if he gets a 1 on the dice and a 1 on the spinner, he has 2. 2 and 1 makes 3. 3 and 1 is 4. 5, 6, 7. Down here we're talking about a 1 and a 2, so that's 3. And it'll just get bigger from there. 6, 7, 8. Here we're talking about a 1 and a 3, which makes 4, 5, 6, 7, 8, 9. How many outcomes are there? Okay, there are 1, 2, 3, 4, 5, 6. 1, 2, 3. So 6 by 3 is 18 outcomes. How many outcomes give an even result? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And write down the probability that the result is even. So it's 9 out of 18, or if you simplify it, it should be a half. Sorry, just to make sure I have everything right. 18, 9 and a half. Okay, question 2. Question 3. During a survey, Nick asked people to state the number of children in their families, and here's the results. Write down the number of people who took part, so you just count everyone. So 1, 2, 3, 4, 5. 1, 2, 3, 4, so that's 20 people. Complete the frequency table below. Okay, so how many zeros? 3 ones, 5 twos, 1, 2, 3, 4, I think 5 threes, 1, 2, 3 fours, 2 5s, 1, 2. Okay, so it always seems like a really easy exercise, but I would always check. So they should all add up to 20. 3 plus 5 plus 5 plus 3 plus 2 plus 2 is 20. So the odds are you're right. Just let me check I am. 3, 5, 5, 3, 2. Oh. 3, 5, 5, 3, 2, 1. Does that even add up? It doesn't. Huh. Okay, well they're wrong. We're right. There's definitely 2 5s there because there's 1 there and 1 there. Okay, so we'll have to take the rest of their answers with a pinch of salt because they are wrong. Okay, so display this data graphically. I suppose a bar chart is probably the easiest thing. So, no, that not work. So if you put a line down here, and then insert another one, and go across. Sorry, this one is going to be the number of families, and this is going to be the number of children. So a certain number of families had no children. 1, 2, 3, 4, 5. Yeah, and what was the biggest number? 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remember what I told you, that the bars had to be separate when you were doing a bar chart? I'll be able to do this, I wonder. Let's try. Okay, so how many families had 0? 3. Okay, so 3. It's not bad. So 3 families had 0 children. How many had 1? 5. So up, across, and 5. And 2 was 5 as well. 5, and then 2, 2. Oh, am I missing? Sorry, 3, 2, 2. So there's 3. This one goes to 2. Ooh. Okay, it's not perfect, but it's pretty good. Okay, so my bars are all the same width. There's a gap, and it's the same gap in between every bar. I have labels on my axis. This is the number of children, this is the number of families. I think their bar chart is obviously, oh my god, this is really bad. Anyway, they don't have their gaps, so that's wrong, and obviously their 5 is wrong. Okay, so anyway, one person took part in the survey was picked at random from the group. The probability that this person has 3 children in their family is 0.15. Show that this is correct. 3 children in the family, so there was 3. So that's 3 families had 3 children in the family out of a total of 20 families asked. So if I do 3 over 20 in my calculator and press the SD button, I get 0.15. Okay. And Nick expanded his survey to include a wider group of people. He also asked the participants the age and gender of the children in their families that are aged 12 years or younger. The results are partly shown in the table. Use these results to complete the table. Okay. Well, I can get this one because 6 plus what makes 14, because this is the total, so this is 8. Isn't it? I can get this one. 14 plus something plus 21 has to make 42. So if I do 42 minus 14 minus 21, I think this has to be 7. So then this has to be 3, because 3 and 4 make 7. Then 20 minus 6 minus 3, this is 11. Oh, this one now is 10, because 11 and 10 makes 21. Then 10 and 8 is 18, 19, 20, 21, that's 22. Oh, that was kind of harder than it looked. See, they have it right. 3, 11, 8, 10, 22, yeah, and 7. Perfect. I kind of spoke how to do that, so hopefully you got that. Nick displays the results for the totals of each age group on a pie chart. The sector angle for the age group 4 and younger is 120 degrees. So that's 14. So 14 children is 120 degrees. Work out the sizes of the other 2 sectors. Okay, so 14, so the 5 to 8 total was 7. Okay, so that's actually easy because that's just half. So that's 60 degrees, yeah? And then 21 children, so 21 is 3 times bigger than 7. So if I take 60 and multiply it by 3, I get 180 degrees. Okay, so 14 children is 120. 7 children is half of 14, so I halve this to get 60. And then 21 children is 3 times bigger than 7, so this has to be 3 times bigger. Now, does that work? 120 plus 60 plus 180? Yeah, 360. Okay, so this is 60 and this is 180. Okay? Now, complete the pie chart. Okay, so I'm not really going to be able to do this because I don't have... I can't do, like, can I use a protractor? I don't think I can. Let's have a look at what we have. No, I don't see any way I can measure the angle. No. No, so I'll just show you. But basically, right, just as a starting point, you would start here. It's horrible, let's try that again. Okay, so you draw your line here to start. Okay, and then you would place your protractor down here and measure your first one, which is 120. Okay, so you'd measure from here, you'd measure 120. And wherever you land, you would put in your line. Yeah? And then you'd move around to here. So put your protractor down here and measure 60. Well, these are not right. So measure 60, so that's my 60. And then the last one should be 180. So this down here is your 180. So you don't need to measure the last one. Okay, so I'll just show you what they have. Okay, so they would have started here and they measured the 60, then the 120, and then the 180. I mean, it doesn't actually look horrible. Make sure you put in the angles and put in what it represents. So for mine, this would be 120 degrees and it would be 4 and younger. This would be my 60 degrees and it was a 5 to 8. And then this is my 180 degrees and 9 to 12. Okay? So yeah, I'll send you this anyway, but that's what it should look like if it's done perfectly. Okay, and the last question, June is carrying out a survey into the amount of chocolate people eat a day. The following is a question from her survey. Too much chocolate is bad for your health. How many pieces of chocolate did you eat yesterday? Tick 1 box only. Explain why this question is biased. So it's biased because in this first line, she tells you that too much chocolate is bad for your health. Okay, so then you're then asked how many did you eat? You're like, oh my god, I can't tell her I ate 6. So you're pushed down this way. And if you did eat 6, you're probably going to say 3 to 4. And if you had 3 to 4, you're probably going to say 1 to 2. Okay, so the question is biased because in that first sentence, she gives her own opinion. Too much chocolate is bad for your health could be seen as influencing the answers. Okay, that's how they've phrased it. But anything to do with that first sentence, giving her opinion, and then it will affect the answer of whoever's doing the survey. So explain one other reason why this question is not suitable. So one of the things you look out for here, which I'm looking for, is an overlap down here. So sometimes they say like 1 to 2, 2 to 3, 3 to 4, and you can't do that. But she hasn't done that. How many pieces of chocolate did you eat yesterday? Like, I suppose the only thing is she didn't say 7 or more. What are they saying over here? Yeah, so you only need 1, okay? And there's the one I suggest. Sorry, I can't. So I said there's no box for those who eat more than 6. You could also say there's no box for those who don't eat chocolate, so 0. What's a piece of chocolate? So, like, I don't know, if it was over Easter time and you bashed up a Easter egg, a piece of chocolate could be pretty big. Yeah, pieces could be seen as a very narrow sample. Okay, so any of those. Okay, so there was no 0 box and there was no more than 6 box. And then you could go into kind of more detailed things like the word piece not being very technical. All right, that's the kind of stuff you're looking for there. Rewrite the question in a suitable form. So how would you rewrite it? I mean, you could go into grams, like how many grams of chocolate did you eat yesterday? So there's a specific measurement, something like that. And you would obviously definitely include a 0 and a more than. Okay, so yeah, grams is what they did. So how much chocolate did you eat yesterday? Less than 120 grams, between 120 and 240 grams, or more than 240 grams. I mean, you could definitely argue that people wouldn't have a notion how many grams they ate. You'd have to then, I'd say if you were doing that survey, you'd have to have like a Mars bar there and explain to them, right, a Mars bar has this many grams. So like I have issues with that question as well. But anyway, something like that, okay? So be more specific about the pieces. And I think the big thing is make sure you have an option for them eating no chocolate and for them eating a lot more than that 6 pieces. Okay, so put a tick in the box to show what type of data that is. So is it categorical or numerical? So how many pieces? The answer is going to be a number. So that makes it numerical. And even if you go with the grams, it's still a number. Okay, Jacob asks everyone in his class to donate. Oh, this is a new question. Jacob asks everyone in their class to donate all the coins in their pocket to a charity. The stem and leaf diagram shows the value of coins received from each student. Okay, so 3 and 6, I assume it just says 36. I assume it means 36 cent, and then 37 cent and 44 cent, 44 cent, right. So what is the mode of the data? The mode, which hopefully you've learned of, is the most frequent, so the number that appears most often. Here it is here, but remember it's not 6, you have to combine it with its stem, so it's 56. Yeah? The median then, so we need to go find the middle number, so here's the first and the last, cross them off. Second, second last. Third, third last. Fourth, fourth last. Fifth, fifth last. Sixth, sixth last. Seventh, seventh last. Eighth, eighth last. So it's this one, but again, it's not a 7. Combine it with its stem, it's 57. Okay, we'll just check those. Sorry, that was the previous one. So it was numerical because the answer is a number. This one, there was 3 56s. It is cent, so 56. And 57 is the median, which we got. The range, so the range is the biggest number minus the smallest number. So, can't really see it. So 85 and 36. So I do 85 minus 36. And I get 49 for the range. 49. The total value of all the coins is €10 and 2 cents. Work out the mean. So the mean is the average, and that's where you add everything up and you divide by the number of numbers. Okay, so they've added everything up for you. It's 1002, so that's the top line. And then the bottom line is how many numbers are there. Did we figure that out? No. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 17. It's going to divide by 17. So I get 0.58941117, and it continues. It's money, so it would be 2 decimal places. So it's so it's 58, but the following number is a 9, so that will push it up. So it would go to 59 cent as the mean. Yeah, so here you go, there's your big number. It's 58, but you look at the next number when you're rounding, and the next number is bigger than 5, so it'll push that 58 up to 59. Oh, and that's it. Okay, so just one more exam and then we're finished our revision schedule and everything in the course has been revised. So I'll give you your new booklet today, which is on area and volume and arithmetic. So it's financial maths and applied measure, I think it's called. Okay, and that's for this week, your test on Friday, and then that's it. So I think you'll have like your week of solid study and ask me questions and whatever, and then the test will be the following week. I think that's right.